Hello everyone! Today I'm going to show you how to repair a laptop battery that has unbalanced and deeply discharged cells. I'll explain how to safely pre-charge the cells and balance the pack in order to bring the battery back to life. For this job, I'm going to use the NLBA1 Laptop Battery Analyzer and the IMAX V6 Sky RC. First, let's connect the battery to the NLBA1 analyzer and read all parameters. Since the cells are deeply discharged and unbalanced, the BMS chip has not enough power to run and communicate. We need to wake it up by supplying external power using the power on functionality. Now we can read the parameters. Looking at the cell voltage, we can see that the cells are over-discharged and unbalanced. That's the main reason why the chip is locked. The cell balance status should be balanced and green for a good battery. Note that there are situations when the cells are not only over-discharged, but they are also bad. It makes no sense to recover such batteries because the cells are chemically worn and nothing can recover them. Now, a very important question. How do we know that the cells are still good and only over-discharged? We can estimate that condition of the cells by checking several battery parameters. The cells are still considered to be in good shape if the health is good, let's say above 70%. Health showed the least battery capacity measured by the chip. Another parameter is the cycle count. A lower cycle count, let's say under 300 cycles, means that the cells could be still good. The same applies to the manufacture date. A newer battery could have better cells, let's say not older than 5 years. Now, to unlock the chip and make this battery work again, we need to balance and pre-charge the cells first. Most battery controls require at least 3 volts per cell to clear the under-voltage safety flag. I will charge the cells to around 3.5 volts to ensure they are balanced correctly. In order to pre-charge and balance the cells, we need to open the battery case. Let's do that now. I'll be using a thin precision blade to open the case. While opening the battery case, avoid short circuits because lithium cells can deliver very high currents. It is best to use plastic tools to avoid accidental shorts. Here we have the BMS with the cells. For pre-charging and balancing, I am using a dedicated tool, IMAX Sky RC, that can do both functions automatically. What we need to do now is solder wires from the IMAX balancing connector to our cells. This connector will help the device detect the cell voltage and balance the cells. The first wire goes to the negative terminal of the first cell. The second wire goes to the positive terminal of the first cell. The third wire goes to the positive terminal of the second cell. And the last wire, the red one, goes to the positive terminal of the third cell. Now I will solder 2 wires so I can connect the charging clamps to the end of the cell pack. Always place the black probe first. We are all set. Let's get to the Charge Master application. The app already reads our pack and cell voltages. The IMAX charger works only if the cells have above 2.5 volts, so I charge the cells with a laboratory power supply until the least charged one reached 2.5 volts. Since the cells are still unbalanced, this device remains in use for the balancing and charging process. All we need to do is to set the battery type, ours is lithium-ion, the charger mode, in our case balance, the cell number, I have only 3 cells, and the charging current 0.5 amps. I've set a lower current because it helps balance the cells better, especially on lower voltage cells. Now press start. Here we see the cell voltages in real time and the current graph. And here is the back voltage graph. All that's left to do now is wait until the cells reach around 3.5 volts. Done. Now our cells are charged and balanced. Let's disconnect the balance wires and the clamps from our cells. Now reconnect the battery to NLBA1 and check the parameters. As you can see, the cell voltages are good, but the battery status is still locked. That's where our magic reset function comes in. Let's go to the reset menu and do the necessary operation to clear the chip errors. We need to press Rechip Info. As we can see, the chip is sealed and it has the cell under voltage flag active on the PF status register. That is why the chip is locked. I'm gonna unseal the chip. The best practice is to back up the original EEPROM before making any changes, just in case the EEPROM gets corrupted. Now, let's clear the errors by pressing the Clear Chip Errors button. The Clear Chip Errors button clears the error flags stored in the battery chip. These flags block charging and discharging MOSFETs. Looking back at the battery info parameters, we see that the battery is now unlocked. Let's make the final test, the charging test. The current is rising and the battery is charging fine. Now, let's put the battery back together. And that is how a battery can be easily repaired by balancing and pre-charging the cells. And most important, resetting the chip using the NLBA1 device. If you have any problem with the battery, please post on our forum. The link is in the description of this video. That's it for today. Thank you for watching. Please don't forget to subscribe for more videos. Feel free to give a like or leave a comment. See you next time.